Okay, guys, so welcome. The recording has been started and we can start. So, welcome to this demo, everyone. Cloud Performance Engineering and DevOps. So, this is Roshan. I'll be the instructor of this particular course, and I'll be leading you through this demo and the course journey. I'll talk about the course in some time, and before that, I would just like to introduce myself. So, I'm having around 15 years of experience in IT, uh, predominantly working into performance engineering, Java, Python development, uh, into microservices as well, development. I'm a certified cloud professional, multiple cloud certifications I have: AWS, Azure, GCP. Involved into automation, with various technologies: Java, Python, Terraform, Ansible, PL SQL. So self-scripting, all. And currently I'm a principal SRE and a principal performance engineer, DevOps professional with one of the, I'm doing a consulting work with one of the prominent companies. And teaching is one of my hobbies. I do like to share my knowledge. So here we are. So this is going to be the agenda of our discussion. I'm going to start with a question. I would like to know your opinion on that, and then we'll start with some introduction about the software development and deployment evolution, how software has been developed and deployed over the period of time, over the history, and we'll introduce about the course. We'll set the expectation, and you can ask any questions you have. You should know, the idea is to, you should know about this course, how we're gonna go about this course, and you can ask the questions. Okay, so let me get started with the question first, and I would like everyone to attempt this question. Okay. So if I ask like this question, like performance engineers, right? We are performance testers, engineers, and I hope most of us who have joined this forum from the performance background, performance domain. What do you think that these technologies, these words, that whatever I've listed here, DevOps, microservices, containers, cloud, are somewhere nowadays from last couple of years are somehow getting related to performance engineers? Do you agree with me on that, or just I would like to know, understand your point on this, based on your work experience or what you're listening or working in your companies. Do you get to work in these technologies, guys? Anyone can unmute yourself. You can unmute yourself, or you can write in the chat, whatever you feel like. Do you think that performance engineers are expected to know this?
Yes, Roshan, we should know this.
Right. Sojna has yes, commented yes. Sirisha has put yes. Meghna has put yes. Right, and absolutely. Your good name, please. The person who unmuted, Megha, has also unmuted, has given yes. So absolutely, Ravindra, Swami, everyone. There is no doubt in this, because looking at the current trend that we are currently in this, we are in the transition phase in IT. We are talking about microservices now. We are not talking about monolith application. We're talking about microservices. We're talking about where do we host these microservices. We host microservices in containers. We're not talking about on-prem now. It's all about cloud. Everyone is going for cloud service providers. Could be AWS, Azure, GCP, and in all this we need automation in place, and that's why we're talking about DevOps. All these technologies, and as part of performance engineer tester, we need to contribute in this. We need to know, understand microservices. We need to do microservices testing using various tools. Jmeter, I would say, on top of my mind. And if you're having troubleshooting applications, your application microservices could be developed in Java or in other language. So you need to troubleshoot your application as well, understand where is the bottleneck. And without cloud knowledge, without infrastructure knowledge, you very difficult, because you need to architect also. The architect from keeping performance in mind. So all these technologies, whichever I have mentioned here, is expected to know this. Performance engineers, or in general, anyone, I would say, whoever wants to be in IT, grow in IT, they all need to know this, and particularly performance engineers, because we need to be everywhere, right? We need to understand the root cause, troubleshoot performance issues at any layer, whatever layer it could be. It could be infrastructure layer, it could be the application layer, or it could be somewhere the database layer. It could be anywhere. It could be at the network layer, we have to be everywhere. We need to know about all this. So absolutely, as you guys mentioned, yes, we all need to know this. Uh, Going back in history, okay, let's go sometime back in history around 1980s and let's understand how the software were developed and deployed over the period of time. So if you look at back in 1980s, let me just start my pointer. So if you look at back in 1980s, if you look at the development process, we were all waterfall model, and mostly the application architecture were monolith application, right? And what we used to do, we used to mostly use big physical server, and we used to install, deploy a tiny little application. We used to waste a lot of resources here. And that time we don't have the concept of it, we didn't have the concept of cloud, we were using data center. If you have a business idea, if you want to have some software, you don't have any other option, you have to deploy your own data center, you have to set up your own data center, then only you can run your software application and deploy it. That's how the things were quite difficult if you compare from now, where we're dealing with these technologies back. And the transition, we are still, most of us, I would say, are in this transition phase, but I would definitely say that 30-40% of the IT crowd has already been transitioned and they're into full-fledged DevOps, microservices, containers, and cloud technologies. We are all working. So after waterfall, we went to agile, right? We all understand where the software development in the waterfall, we developed the application at once and then we started a test, and there was no looking back. And if there any mishappening or if any decision has gone wrong in the architecture, we cannot do anything about it. So that was that difficult waterfall model, but it was good to start with something to start with so that we can improve on that. So we improved on that. We went to agile, from waterfall to agile, where we understood, let's not develop everything all together, let's develop in phases. So we call different phases, sprint 1, sprint 2. We did the one phase development, we tested it, then we went to the customer client, we asked for their feedback, we got the feedback, we improved on that, we developed some other module, and that's how the software development went on. And we are still in the phase of agile. It's not like we cannot say that we are not agile, we are agile, but we have improved on that in such a way that we are trying to automate every step. The idea of DevOps here, that as soon as the developer completes writing its code and upload to a GitHub, let's say any central repository, the idea is to everything, all the process after that should get automatically triggered. The code build using Maven tool, uh, or the code could get deployed in the testing environment, automatically deployment, and then all your automation QA scripts, Selenium scripts would get automatically triggered. After that, performance job, Jmeter job would get triggered, and if when all the jobs are successful, then only the code is allowed to deploy in production. So that we are talking about automation when we talk about DevOps here. We were using NTR application. We're still using NTR application, where we use web server, application server, DB server, right? And then from physical server, we did a very wonderful thing around 2000. We found something called virtualization. Very important thing. Now we were able to utilize the resource better, where back in 1980s, where we were just deploying one tiny little application to big physical server, we were wasting a lot of resources. We created the VMs out of that physical server, we virtualized the hardware, we installed something called virtualization software, and then we created VMs, multiple VMs we created, and then we could in each of the VMs we can run workload, we can run application, right? And that's how we were able to efficiently utilize the resource. And there was some hosting, there were some providers came who were trying to, you could have hosted your application. There were some providers around 2000. But if you look at the current situation now, this virtualization, we are trying to further break into down. We are trying to further make sure that the one VM is completely utilized. Then only I'm going with the another VM. So what we are doing on top of one VM, we are creating multiple containers so that, let's say if you're a three-tier application, you needed three VMs to run your workload. Let's say if you're a three-tier application, web server, app server, DB server, you needed three. Let me just draw this. So let's say you use one VM for the web server, one VM for the app server, one VM for the DB server. So you needed three VMs. So what this containerization would enable you, that in one VM itself, you can run three containers. You can run these three containers in one VM itself. And one container can run as your web server, another container can run your app server, another container can run your DB server. So further, the goal has been the same: efficient utilization of the resource. This phase was called virtualization, and this phase is called containerization. We are in this phase. And that's where we're talking about Kubernetes, pods, containers. Kubernetes is the container orchestration engine. Everything is gelling well together with containers, because if we're talking about microservices, where do we host the microservices? We don't talk about a multi-application now. We're talking about microservices. And where do we host these microservices? We host these microservices in containers. And to create containers, what we need to do in a VM, we install something called container engine like Docker. We install that, like in the physical server. When we needed to create the VMs, what we installed? Virtualization software. We install that, and then we created VMs. In one VM, I'm going to install something called container engine like Docker, and I can create multiple containers. The goal has been the same: efficient utilization of the resource. If my one VM is completely utilized, fully utilized, then only I'm going to run my workload in the other VM. That has been the goal, right? And we are in the phase of cloud now. We have got major cloud players in the market now: AWS, Azure, GCP. We don't know if you have one idea. If you want to run your workload, it's not about setting up your own data center. You can just go to cloud, rent one server, two servers, three servers. You can just pay less than $1,000, and you can just run your workload, and you can have your application up and running. It depends on your workload and how many servers you have provisioned. That cost would depend on that, but you don't have to invest like a data center to run your workload if you have a business idea. Today we are in that phase. So learning cloud, learning containers, learning Kubernetes, learning Docker, right? Learning what are microservices, how it is different from multi-application. Learning DevOps is the indispensable part of current IT transition now. And if we are not in this phase, we are behind, right? This is what my understanding is, and that's why I have come up with this course, which is going to enable the performance engineers to come and be in industry ready, and be the whatever the expectation of the industry is, they can fulfill that, and they can grow their career, right? So any questions on this part before I move on to my next slide? Okay, I take that silence that we're all good. Uh, so coming to the course syllabus, right? This particular course, as I have been talking about, is design is I've made this course around all those four topics that we have discussed. To start with, we're gonna learn about AWS. This particular course, AWS, because we have major cloud service providers, others as well like Azure and GCP, but AWS by far has the largest market capture, 40%. 40% of the market capture. So we're gonna learn AWS, and that's the first thing to get started with. And trust me when I tell you that why we're learning AWS, you can ask why can't we learn Azure and GCP? Just mark my words. If you know one cloud service provider, it's so easy to learn other. It's so much easy to relate other cloud service provider, be it Azure or GCP. So good to start with one cloud service provider, and then I'm going to talk about what all the relevant service. See, all the cloud service providers are very much similar. If you have worked in let's say performance testing tools, or let's say APM tools, if someone would say I have worked on AppDynamics, that person can also work in Dynatrace. He just needs to know the UI and how to pick things up, right? The concept wise remains the same. It has to capture the metrics. There has to be a metric, right? So same thing goes for the cloud service provider as well. So you need to know one cloud service provider and you can learn others quite well. I do understand this particular topic. I have added from a lot of folks who have joined this course, and they were very much there was very much low in Linux command line. Current we whatever we discussed today in microservices, containers, we all those things run in Linux operating system. And good understanding of Linux command line operating system is very much required to troubleshoot any application, to work on anything. So I have a second module called Linux command line. I'm going to discuss about that. And then we're going to talk about different architectures that we have, application architectures, monolith application, microservices, what are different. So what are the differences? All those things we'll talk about that. And then we talk about where do we host these microservices. So we host these microservices on containers. So how do we create containers using container engine? So we're going to talk about container Docker now. Docker is one of the popular container engine out there in the market. Uh, your company, I'm not sure if you may be doing a POC around that. You're trying to doing a POC around the container. Some of you would be doing that, I know. So we're gonna understand how this Docker work. How do we create containers from this container engine? We'll discuss about after that we'll discuss about the container orchestration engine, Kubernetes. When you have a lot of containers, how to orchestrate them, how to auto scale them, right? How to auto deploy them. Because Kubernetes, if a company is developed its architecture in microservices and they have a good workload to run, they are going to use Kubernetes today or tomorrow. They're going to use it. Kubernetes is the future today, and Kubernetes from Google. From last 15 years, Google were using Kubernetes. They're still using it. And who handles load better than Google? I don't know for anyone, but the better the best company who handles load is Google, and they have been using Kubernetes. And the entire industry, IT industry, is relying on the Kubernetes, the Google, the experience, the maturity of this Kubernetes, what Google has brought in. All the companies, trust me, they're using Kubernetes one way or the other. Either they're using managed Kubernetes service like from the cloud service providers, EKS, AKS, or GKE. AWS has a managed Kubernetes uh, engine service called EKS, Elastic Kubernetes Service. We're going to talk about that. Similarly, for Azure, we have AKS, and for GCP, we have GKE, Google Kubernetes Engine. A managed service, because we're going to understand what is a managed service when we talk about cloud first, and we're going to understand Kubernetes in general as well. It's an open source. After that, we can understand how performance engineering fits in DevOps. What all different roles are there, so that you are prepared, your industry prepared in understanding what is your expectation at the role, what is the expectation at your job. We'll understand that, and we'll end this with the continuous performance testing in DevOps. How do you, because when you create a DevOps pipeline, CI/CD pipeline, performance job is going to be one of the tasks that a performance engineer or tester would be working in, because they need to contribute. DevOps is at the organization level, and you create automated jobs. So performance job is going to be one of the jobs, right? Uh, After you have built your application, right? Uh, you need to deploy the code in testing environment. Once you do that, the next job which triggers is the you need to do the functional testing, right? So that is the automation QA job. After that, performance job gets triggered. The Jmeter job gets triggered, right? And this is where we're going to talk about the continuous performance testing in CI/CD pipeline. So this particular course is based on these topics. We're going to talk about these topics, and this particular course is going to take around 40 hours. We're going to meet every day, 1 hour, 9 p.m. to 10 p.m. And that's how this is a vast course. A lot of things to be discussed, a lot of things, knowledge sharing has to be done, and you need to learn, practice a lot. So that's about the course. Moving on. So these are the different topics that we're gonna cover in cloud computing. So everything, whatever we're gonna discuss, do it from scratch. I assume that my audience doesn't know anything. about cloud, about Linux, about Docker, about Kubernetes, about DevOps. That's what my understanding is when I take up these subjects. You need to be in you need to be from IT. That is what my expectation is, because when I say some IT word like port and IP, you should be able to understand that. This is what my understanding is, right? And we're going to talk about from very basics, like we're going to talk about everything from scratch. What is uh, cloud computing, cloud, different service models that we have, what is infrastructure service, platform as service, software service, what is deployment model, what is public cloud, uh, private cloud, hybrid cloud, community cloud. Would you understand that? We will all have the AWS account created. Uh, it's a free tier. I'm going to guide you how to create your own AWS account, and we're going to practice things there. Everything I'm going to show you, and you need to practice it, right? And we're going to talk about a lot of AWS services. We're going to cover around 20 to 25 AWS services here. We're going to talk about the AWS regions, AZs, IAM, one of the security services that AWS has. We're going to talk about different storage services that AWS has, and the performance, all from a performance point of view. Remember that. I'm going to talk each one of these topics from a performance point of view. When I talk about different storage services, I'm going to talk about how performance play a role, what you should consider from a performance point of view when you consider storage service. Networking, we're going to talk about that. Very important to understand the architecture. You need to know the networking, and the most important of all, the load balancing and auto scaling group. For a very important for a performance engineer, the load balancing and auto scaling group. How do you configure it, right? Because we are in the wave in the we are in the cloud. We want to auto scale things. We don't want to scale up servers manually. We want to auto scale up, right? If you're a web server, we want to auto scale up. Let's say today I have deployed 4 servers, and let's say I'm able to handle 500 user load. What if all of a sudden 200 more users came in? Do I have to scale up the servers manually? No. We are in the cloud. We can set up auto scaling. And once we do that, automatically the servers will be scaled up based on certain criteria like CPU utilization. Automatically it will be scaled up, and the load be getting distributed across all the servers through the load balancers. So we'll understand that. We're going to understand the out of the box monitoring solution in cloud. We have a monitoring solution like you have any tools if you have heard of host monitoring. So in cloud, we have a cloud watch, which is going to monitor all the services that you provision. So we're going to talk about that. So this is going to be the cloud, all the topics. This particular course only topic takes around 15 to 16 hours of our course part. So around, I would definitely say more than 1/3 or 25%, around 1/3 of our course is in this cloud focus, because I'm going to talk about cloud keeping performance in mind. So that's how we're going to take up things here. Again, Linux command line. Coming to this second topic, everything's from scratch. I assume my audience doesn't know anything. That's fine if you know a few of the Linux command, perfectly fine. But my simple expectation is, or my target, my goal is to get you as comfortable with Linux as you are with Windows. If you know, see, it's only about the knowing things. It's all about commands, right? In Linux, if you know something in Windows, let's say if I ask you, if you have a notepad and if you have a lot of text in that notepad, if I tell you how, just find me a word in that particular notepad, you know how to do that. Open a notepad, do a control F and find it. But if I ask you the same thing, that if I have a file in Linux, do a control F in the Linux, will you be able to do that? Like how many people have to do that, and how much comfortable you are. So we're gonna make you, we will think from a Windows point of view. So if we can do this in Windows, why can't we do this in Linux? It's just an operating system, right? So, and it's all about knowing how to know how to get this thing done, right? So that's how we're gonna take up things. We're gonna learn about self scripting also. In, let's say, if you have any monitoring tool in your company, so you can make use of that to capture CPU memory disk. But let's say you don't have any tool in your company, can you still capture those CPU memory disk during the test time or the test duration? Because that's an important metric, right? That's going to be one of the data points to analyze where is the bottleneck. So we can make use of shell script, and we can write something, and we can just plot the graph of all the CPU memory disks. So we'll understand that as well. So we'll start from basics, and I will take you to the shell scripting knowledge as well in Linux command line. I'm not going to go over everything, but the idea is to do whatever you're doing in Linux, in Windows, same thing in Linux. Let's say if you have to zip a file in Windows, you know that how to do a zip a file, right click zip. But how can you do the same thing in Linux? Can you do that? We have something called tar command. We'll understand that. So that's how it is gonna be in Linux, right? We'll understand microservices architecture, what is one fabrication, what is microservices, right? How it is different. Uh, First of all, we'll make the understanding clear, and then we'll talk about where do we host these microservices, and we host these microservices in containers, and how do we create containers using container engine. We'll talk about Docker, right? And we'll go over various operations that you perform in Docker. We'll talk about Docker volumes, we'll talk about Docker file, we'll talk about Docker compose, right? We'll talk about all these things here in this container engine. And when you have a lot of containers, you need to orchestrate them. You need to auto scale, auto deploy, things like that. So it should be done automatically, right? For that, you need a container orchestration engine. Docker is the container engine, and Kubernetes is the container orchestration engine. We'll learn about the container orchestration engine after that. We'll learn about this. Uh, One of the hotcake in the market. If you can tell you, if you can tell anyone that you know Kubernetes, how would you auto scale things up? You gonna have the upper hand in the interview for sure, right? And we'll talk about DevOps, how performance engineering fits in DevOps, uh, what are different roles and responsibilities a performance engineer has in a DevOps complete life cycle. How can you contribute? What are different roles and responsibility you can be involved into a DevOps, particular as a part of performance engineering? Because the roles, the expectations are changing. In the current world, we are not just doing performance testing. Any 2 years, 3 years can guy do Jmeter run, right? But apart from that, if in a DevOps architecture, if you're having a DevOps culture in cloud Kubernetes setup, your roles and responsibility would be different. You know to be comfortable with these technologies to work and troubleshoot and make a difference in your organization. And that's where this all this technology that we are discussing would come handy, right? uh, Kubernetes is one of the very important topics, and we're going to learn EKS, elastic Kubernetes service. We're going to talk about that. We're going to talk about the AWS offerings of Kubernetes. It's a managed service, elastic Kubernetes service. We'll talk about that. How do we set up a Kubernetes cluster? We have a master and the cluster setup using EKS. We'll talk about that. How do you auto scale pods using HPA, horizontal pod autoscaler, and cluster autoscaler? We'll talk about these two things as well. Most important thing. And how do you monitor when you have lots of containers, lots of pods? How do you monitor them? So we'll talk about CloudWatch Container Insight, because monitoring is one of the very important part that performance engineers are involved, right? So we're going to talk about that CloudWatch Container Insights. So this is what I wanted to cover, guys. Give you a brief about the course, and at last we're going to talk about performance testing in DevOps. So when I talk about continuous performance testing in DevOps, I mean, how do you create a performance job, right? How do you, like, we're gonna use Jenkins as the CI tool, and how would you make use of Jenkins as a CI tool to create a CI/CD pipeline? And when you create a CI/CD pipeline, you need to contribute while creating a Jmeter job. So we're gonna create a Jmeter job, And once the developer, the idea is once the developer, we're gonna create this job. The idea is when once the developer uploads the code to the GitHub, automatically the codes would get built and the codes would get deployed in the testing environment. Once that is done, an automation testing suite would run, right? That is fine, but we're gonna focus on the after that. There should be a job for the Jmeter. Based on the performance plugin that we install using the Jmeter, we will compare with the last build or the performance SLA that we have on the response time on the or the 95th percentile, and we're gonna compare it. And then if the number looks good, only then only this job will be successful, and then only my code will be deployed to production, right? So that's how we're gonna create CI/CD pipeline. We're going to understand Jenkins, how do we install Jenkins, and then we'll talk about how do you set up, how do you trigger or automatically email once any job fails or passes. We're going to do that, scheduling the pipeline with dependencies, and how do you automated feedbacks using email notification. We'll talk about that. How do you create freestyle jobs? These are all called jobs. Jobs are nothing but the tasks that you create, right? So we're going to talk about all these things. Yeah. So that's all I wanted to cover, guys. I'm opening up for the questions. This is what you're going to learn by the end of this course, right? Uh, all the topics are covered from very scratch. That's what this course USP is, and that's what I have understood meeting all the people that has to be the way, because I do understand lots of people are not aware of these things. So that's how this course is designed from very scratch, right? And learn a lot of these things, right? And I can share one link with you. Let me just share that link uh, so that just this is the link, right? You can go over this link and you can contact if you have looking to get more some questions. You can ask questions right now, but you can contact Mr. Kumar, right? You can contact Mr. Kumar at this number, uh, and this is the course detail. You're gonna find all the details here. Some of my demo videos, you're gonna see that, and you're gonna see all the details whichever I have shared. What will I learn by the end of this course, and who can enroll for this course, right? Anyone can enroll for this course, and all the course syllabus, right? And you're gonna find all the feedbacks, testimonials that I have been receiving over the period of time, all the real WhatsApp images I have shared. So let me share this link with you guys, and I'm opening for the questions if you have any questions. Yeah,
Hi, Raj.
yeah. Hi.
Yeah. So the course seems to be very vast. So how much duration you require to cover all the topics?
Yeah, that's a
What
good.
is the plan, and when are we finishing this?
Right. So as I mentioned, it's gonna be 40 hours. Okay, 40 hours, and but I have planned in such a way that over the weekend, I'll be giving you some self-paced material as well if you want to cover it quick, right? But the entire, but that's gonna be my self-paced videos, okay, from this course only, right?
Hmm.
Not any other source. But if this course in general, it takes around 40 to 45 hours, right? So that's the course duration. Let me just
Okay, okay. So what I understand is we also have self-paced videos in case if we have any urgent requirement, we can also go through during the weekends, right?
exactly.
Otherwise, we can follow the course. Okay.
What
So second thing, as you are very detailed in the AWS as well. So with this knowledge, we will be able to cover any of the certifications from AWS.
Exactly. So after this particular course, we're gonna lay a very strong foundation of AWS, and you can definitely go for cloud practitioner and solution architect. But you'll have to groom yourself, and I can guide you on that. but I cannot promise you that this course is going to get you the certification. But you need to. So for sure, I would say the 50% of the work will be done from this course by this AWS, whatever we are targeting, and 50% you need to practice, and I can guide you for that.
Okay, okay, sounds great, Roshan. Thanks.
So,
I have a question. So are we covering all the AWS concepts here, like admin part, or so only the related to the performance engineering area? So how
right.
we are going to cover?
See, the time that we have devoted for AWS cloud is 16 to 17 hours, right? So if I say that I'm covering everything, it will be very wrong, right? AWS is a very vast, around 200 plus services. So my focus is to get you as comfortable which you require in an industry from a performance tester, or to get started, to get you started in AWS, and which is very much good enough, right? So no one, let me just log into this AWS. So no one has known 200 plus services. Mostly people knows about 40 to 50 plus, 30 to 40 services in detail, right? That's how the industry, this is what the expectation is. And even if you ask the experts, no one can tell you that I know all the 200 plus services, right? So it's all about 30 to 40 services, and how well you understand that makes a difference. So we're going to talk about that. And definitely, you can, as I mentioned, 50% of the course syllabus from the architect point of view, we're going to cover that, and 50% I'm going to guide you how to get things done. So there are around 200 plus services in AWS, and it's still growing, right? So that's how it is.
That's good. And Roshan, I have another question here.
Sure.
So in the CICD pipeline job, like we are
Right.
using like what is pipeline method. So are we covering any scripting part here?
See, scripting part, I'm gonna talk about. See, my main focus is not to talk about CI/CD pipeline as such. My main focus is to create Jmeter jobs. See, look at this. Because the understanding should be here. I'm not talking about DevOps and all the CI/CD pipeline here. My main focus is to build how to build a Jmeter job, right? So that a performance engineer or tester joining any company and being expected to contribute in the CI/CD pipeline, that person should be comfortable. So this is what my expectation is in the CI/CD pipeline. I'm going to talk about the job, performance job, which, and I'm going to talk about thoroughly how to create, how to install Jenkins, and how do you create the performance job using JMeter job. I'm going to talk about how do you set up email notifications. We're going to do so the script part. So if, to run the JMeter, you need to run one command, right? That in the non-GUI mode. We're going to talk about that. And to build again, to build the website, you need to run some Docker command. That script part that we're covering, but not, but don't expect a DevOps kind of experience, right? Because that is not designed here. Yeah. But I hope I answered the question.
Roshan Surisha this side. So when you're talking about CI/CD pipelines and you're entirely concentrating on Jmeter, and do you think we need to have Jmeter experience in it to understand it well, or is it fine if we have only LoadRunner experience?
Even if you have a load runner experience, you can also create a load runner job in the CI/CD pipeline. And I'm not going to talk about JMeter as such. I'm going to just talk about how do you create JMeter job. I'm going to tell you how do you run JMeter in non-GUI mode. That's all. Very simple. If you know load runner, it's going to be very simple for you. Can you go on mute, please? It's very loud background voice. Can you go on mute, please? Thank you, Sirisa. Yeah.
Question, I have one question very fast.
Sure. Arun. Yeah.
So moving on the project,
Yeah.
it is related to AWS related,
Yeah.
cloud-based project, which they have given the AWS Workspace, so which is covered in this, which is one of the service in AWS.
Correct. Yeah. Tell me. Yeah.
I'm talking about the AWS Workspace. It's
I'm
the kind
listening.
of remote
I'm listening.
right?
Yeah, I'm listening. Yeah.
So is one of the services in AWS is a separate topic which is not covered in our syllabus.
Correct. Correct. Right. So AWS Workspaces, it is some one of the features to create your own desktop, right? So yeah,
Yes.
we are not covering this particular part, right? So workspaces. So as I mentioned, we're gonna talk about in general topics, right? So around 20 to 25 topic services we're gonna cover. We're gonna talk about EC2. We're gonna talk about VPC. We're gonna talk about IAM. We're gonna talk about cloud formation. We're gonna talk about EKS. We're gonna talk about these things, right? So billing, right? Those things. We're gonna talk about these things more, right? Different security services, different storage services that we have, EBS, EFS, S3. We're going to talk about these things, right? So yeah, but I can just tell you how to get started on that if you are looking for me information on this. But we are not covering as such for this particular topic.
Yeah. Okay. For one project, they have given the workspace area, okay, and in that part they have built the application in the workspace.
Okay.
Just practicing the application access in general. I mean, without
Right.
providing, they are in production in the building production, so they are given the basic access. Like a small configuration of they have provided this AWS workspace to practice this
Right. It is
functional.
not related to. It is just about the getting the desktop experience in the cloud, right? So you can get
Yeah.
started and you can just create your desktop. You can have your quick setup or advanced setup. You can launch workspaces. So yeah, I understand what you're going, but we are not covering as such in this course. But it is if you're looking for any more information, I can help you with that.
Okay. Okay.
Hi,
Yeah.
Roshan. So when is this course about to begin? And
Okay, so it's the first demonstration that we are into, right? We're just going to introduce this. So today is our demo session. I'm gonna start this course. I think from tomorrow it's gonna continue. So if you are already in the WhatsApp group, you'll be notified. So we started, right? So today you can consider like a first demo session, and we're gonna start with the real topics. You can tomorrow, and you can attend some demos, right? And then you can decide what whether do you think it's gonna add value addition for you or not. So yeah, we're gonna start it this particular topic, and from tomorrow it's gonna be the topic that we're gonna talk about more.
okay.
Okay, so Meghna has asked me a question. Virtualization is same as containerization. No, Meghna. Virtualization is not same as containerization. So when I say virtualization, when you say you basically virtualizing the hardware of the physical server, and then you're creating VMs. So what you have to install something called virtualization software, right? Like VMware, or you have VirtualBox, this kind of software you have to install in the physical server, and then once you install that, you can create VMs in the same physical server. I hope you're working in VMs. But when you create containers, when you want to create containers, you take one VM and you install something called container engine like Docker, and then you can create containers. So virtualization virtualizes the hardware, but the container it virtualizes the operating system. So when you create multiple containers, right, in one VM, you don't need separate operating system. But in the case of virtualization, when you create VMs, you need separate operating system for VMs. This is why we virtualize the operating system for the containers, and that's why you don't need separate operating system for the containers, right? So that's the basic difference. I hope I answered your question, Meghna.
Yes, Roshan. Thank you.
Sure.
Hi Roshan.
Yeah.
What are the study materials we are going to get as a part of this course?
All right. So let me show you one drive. So everyone would be getting. So these are all my batches, which you see here, different batches, which I have been taking up August. So let me just show you one of the latest batches. So you're gonna get all the PPTs, which I'll be going over these sessions for cloud computing, Linux, container engine, container orchestration engine, Jenkins. You're gonna talk. I'm gonna give you some shell scripts. I'm going to give you some YAMLs to work on Kubernetes. I'm going to give you some user data. All the important links which you require just to have a better understanding of cloud and the performance knowledge. I'm going to give you this. All these things I'm going to give you, everyone. I'm going to add you here, like I have been adding like most of, like if I just open any other course, let's say if I'm opening this particular, so I have been adding. So for every batch, I'm gonna create something like this drive. I'm gonna add people here. So if, let's say for this August batch, I would have added around 50 people. So I would be adding something like that. So you'll be getting all these access.
And along with that, we'll be getting the recorded session as well.
Absolutely,
Right.
absolutely, lifetime. Yes.
Okay.
Yeah. Any more questions I can answer?
Just a random question again.
Yeah,
Roshan.
please go ahead. Yeah.
Yeah, so the recorded session along with the PPTs would be sufficient to clear the interviews for cloud performance engineering.
Exactly, right? So yeah, you should be, the idea is to, you should know the knowledge, right? And I'm gonna give you the knowledge, right? So those recorded sessions are the real day-to-day class recordings. So yes, you're gonna clear it. Yes, absolutely. You're gonna get all the knowledge. So do you have any doubt after going over all these things, you will not able to clear it? Absolutely. You're gonna practice it along with me, and once you gain knowledge, absolutely. In these topics, you will always have an upper hand.
It's a practical course, right? Like you will do something, and along with that, we'll also try and do something from our end.
Exactly, but not during the session. I may not have that time luxury. We don't have that 1 hour. So I will be doing it. It's a complete hands-on training. It's a complete hands-on. You're gonna watch me do, and you're gonna practice it the same thing later.
Okay, thanks.
I have a question here. Like, can I?
Yeah, absolutely. Go ahead.
Yeah. So, what is the course timings? Like, if it
Okay, it's gonna be 8 to 9. Sorry, 9 p.m. to 10 p.m. daily. 9 p.m. same time as you're meeting right now. 9 p.m. to 10 p.m. on the weekdays. Monday to Friday. We can decide on any one day. We can take leave also. We can meet 4 days a week. That's fine. But it's gonna be on the weekdays, Monday to Friday, 9 p.m. to 10 p.m. IST, Indian Standard Time. So if you're in a different time zone, you can convert that. Yeah.
you don't have any sessions on weekends, right?
Weekends no.
Do we
But
get any course completion certificate for this after the session?
right. The Isha Training Solution provides that. Yes, course completion certificate. Yes. So you're gonna go. I would highly request or recommend that this particular link, go over this link, and you will have all your most of your doubts clear. Yes. So this course completion certificate and all the uh, feedbacks that people have been giving, all the WhatsApp, they have attached this Training Solutions. So yeah, you can go over this. And there are some demos videos also. You can go over them with a better understanding. How do I go about taking any subject, right? So you will get some fair idea about that as well.
One more question.
Do we get separate certification for each topic or the club
No, no,
with
no,
one certificate?
no, only one for the course. Yeah.
Because that was containing only DevOps.
Which one? It's this course, Cloud Performance Engineering and DevOps, for the entire course.
Okay.
Yeah. Someone else wanted to ask something?
Yeah, Roshan, I have one question.
Yeah.
While working on the Dockers and containers, so are you covering that scripting part also? Like if we want to do any scripting for microservices or in Docker or container, so what are the parameters we should consider, or what are the challenge we may face during the scripting part or
Okay.
during execution? That also you cover,
Okay,
or
that is completely into DevOps. Okay, what you're asking right now is completely into DevOps part, right? What Where I come into picture to help performance engineers talk to DevOps professionals better. So I'm going to tell you how do you create containers, how do you go inside the container, how do you see file system inside the container, and if you want to edit something, if you know what parameter to change, you can change it, right? So you can write a shell script for that. I'm gonna talk about how do you create an image using Docker file. I'm not sure about exact expectations you have it here, because I'm going to tell you how do you create containers. I'm going to use Docker Compose to create Docker volumes commands, all the commands, Docker operations command. I'm going to talk about that, different commands that you have, common Docker operations. How do you create Docker? If I have to just show you that particular slide, what all I'm covering here, let me just go over that container engine, what I'm going to cover. Let me just allow me a moment, it's loading up. So first of all, I'm going to get you comfortable with Docker and I'm making an understanding of Docker, how virtualization and containerization different, and talking about different Docker operations that you have. I'm going to talk about all these commands so that you understand how you create containers, how do you work with containers, how do you log in inside the container, how do you do a port mapping. I'm going to talk about how do you use Docker file to create your images. I'm going to talk about different your Docker volumes. What is the concept of Docker volumes? I'm going to talk about the administrative part of Docker Compose. When you have a Docker Compose, you can create multiple containers at the same time if you have a Docker Compose file. For example, if you have this Docker Compose file, if I run this, how to run this? If I run this, you're going to create DB and your WordPress website all together. Then I'm going to talk about the administrative part from performance point of view. How do you check on logs? That is more important. How do you look into the system? All those, and how to look at the stats, the CPU utilization, the memory utilization from a performance point of view, right? Those parts. I hope I answered the question. What are you looking for?
Yes, Roshan.
So,
Like mostly, you will be covering how to use Docker and container. I was supposed to ask, if we want to, if we want to do any performance for an application which is hosted on, let's suppose Docker. So during the scripting part, it will be helpful or not, like how we
exactly.
can
So
cover.
you the Docker stats. What do you doing load test? What do you need? You need to know the stats, right? So for these containers, how much is the memory footprint, CPU footprint? You would like to know that, right? So Docker stats is what you're gonna
Ah,
help.
yes.
Yes. So Docker stats, you can write a shell script around Docker stats to get you all the metrics that you're looking for. And the Docker logs, I'm going to show you how do you use make of these commands for the administrator and the monitoring purpose. I'm going to show you that.
Okay, thanks.
Sure. Any more questions? I have 4 minutes, guys. Okay, I take the silence that we are all good. So thank you so much, guys, for attending the session. I hope you learned something today and hope to see you soon. Thank you.
Thanks.
Thank you.
Thanks, Roshan. Thanks,
Sure.
everyone.